Yes. Hi, hello. Hi, Sagar. Hi, Sneha. Hi, Jansi. Good evening, Jansi. How are you all? Good evening, Sagar. Guys, we'll start our session. Yes, Sneha. Right. Hi, I'm good. Thank you. We'll start our session today. Already time हो चुका है. Time आ गया है. Good evening, Akila. Okay, guys, we'll start our today's session. And welcome to all of you once again. And only 9 members are there. No problem. Okay. After a couple of minutes, they might be joined. Good evening, Yashaswini. Good evening, Sanket. Okay, guys. In last class we started the gas law, right? Gas एक scientist है, उसके वजह से एक law आ गया. We call that one as a gas law, right? According to him, actually any closed surface in a closed integral, okay, gas law बोलते हैं in a closed integral E dot dA, our surface integral value will be equals to Q by epsilon naught. Means charge present inside the that surface what we are considering Gaussian surface divided by epsilon naught. Okay, epsilon naught means permittivity in a free space. Okay, this value will be equals to electric flux that is denoted by phi E, Gaussian surface. Yes, right. Right now, this topic only yesterday we talked about, right? And today also same thing, Gaussian surface only, because it has a large amount of applications in our 12th standard right now, and few good numericals. We'll solve this today class. Okay, and then before that, let us take a quick recap what we discussed in a previous class. थोड़ा सा quick recap. Gauss law theorem पढ़े थे आप, right ना? In a closed integral, ये surface है. Okay, इस surface के अंदर क्या था? एक charge था. एक charge के वजह से at this point, due to this surface, what will be the flux we calculated? Correct ना? First, what we did? Actually, we took a small area. करेक्ट ना, इस स्मॉल एरिया में कितना इलेक्ट्रिक फील्ड घुस रहा है उसको कैलकुलेट किया, दैट इज अ फ्लक्स. एंड टू कैलकुलेट द थ्रू आउट द फ्लक्स, फ्लक्स क्या है टोटल एरिया में, नॉट ओनली दिस, इन दिस एरिया नॉट ओनली द इलेक्ट्रिक फील्ड लाइंस आर मूविंग, हियर आल्सो इलेक्ट्रिक फील्ड लाइंस आर आल्सो मूविंग, here also electric field lines are moving, here also electric field lines, like this in all the area electric field lines are moving. Means we need to take all the small area segment like this. Okay, now we need to integrate all the area, means adding the all the area, it will give the total flux. करेक्ट ना. टोटल फ्लक्स के लिए एक आंसर भी आया था इस फॉर्मूले के लिए, क्या था इधर देखो, इधर Q by epsilon naught. We proved this one, that's it. Okay, in a closed integral E dot dA value is equal to Q by epsilon naught. From this point I told you that in a Gaussian surface, inside the Gaussian surface, okay, whatever the charge are there, that only creates the electric field. If charge is not there means flux value will be equals to 0. Correct now? And Gaussian surface, what you're considering, no, it is not an limited one. Okay, you might be take a larger area also, there is no problem. Shape and size not dependent. Take one, koi problem nahi. And then we took a application of Gauss law also. Application of Gauss law mein first application we studied that uniformly charged linear wire. Okay, infinite length का wire का वो actually uniformly charged. Okay, the charge कितना है actually बहुत charge है. It's an infinity means बहुत charge है. That's why charge calculate करने के लिए क्या करते हैं हम इधर charge density will take. Either linear charge density. That's why we took lambda is equal to Q by L, charge per unit length. Okay, from this point Q के equation लिख दिया हम lambda into L. We utilize this one, right? Right, and also we calculated here the electric field intensity due to this wire. It will be here. Here it is there. Okay, I will write that one. E is equal to 1 divided by 4 pi epsilon naught 2 lambda divided by r. Okay, due to linear wire, electric field intensity value will be proportional to 1 by r. Okay, 1 by r के तरह relation दे रहा है. Clear na? And also we prove the Gauss theorem. If inside there is no charge here, charge value will be 0, right? In this diagram. Extra I explain this one. Inside this one there is no charge. Just electric field lines are coming from infinity, right? From infinity electric field lines are coming. That's why flux value क्या होता है इधर? Flux value will be here 0, because according to Gauss law, if any charge will be present inside the surface, no, then only it is creating the flux, or else no flux, right? These are all the points which we covered in our last class. And then yeah, done. If you had any doubt guys up to this point, let me know in a chat box. Is there any doubt? No doubt. Cool. I'm asking everyone. I'm getting only one response. Akila, Bharat, Devegowda, Manthan, Purva, Rajat, Sagar, Sanket, Sridevi, Srujan, Swami, Swati, Ballari, Susti. Yes, try to give a response, yeah. Okay, cool. Okay, then if it is understood means I have a small question here, guys. Let me know the correct answer for this question. What is the electric flux value for the given configuration according to the Gauss law? Gauss law prakar ke, what is the electric flux for this configuration? Here two charges are there inside. Might be it is not visible means try to look at here properly. Screen is not visible, huh? Arey yaar. Just a minute. You have to tell me in initial only, right? Okay. Now is it my screen is visible? Yeah, that's great. Okay, the question A, what is the flux value for a given configuration according to the Gauss law? Okay, Gauss law use करके इसका flux बोल दो मुझे. What is the value of flux? Guys, are you there? Simple है. Gauss law का flux value क्या है? Electric flux value is equal to Q enclosed. Okay, Q enclosed by epsilon naught. Yes, right? Correct ना? इसका meaning है whatever the charges present inside the surface. Now we need to consider on surface. Okay, किधर consider करते हैं? मान लो this is the surface. I'm considering Gauss surface. Okay, इसके अंदर चार्ज है ना, कितना है देखो, charge 1, charge 2, two charges are there, correct? Then we need to write the flux value like this. Flux value will be equals to charge inside. Actually, charge is a scalar addition. Correct na? That's why while writing this charge addition, we need to add these two charges. Means Q plus Q divided by epsilon naught. Clear enough? Then electric flux value will become out to be 2Q divided by epsilon naught. That's it. 2Q by epsilon naught means charge इसके अंदर कितना है ना उसको add करना. That's it. Okay, if in case, in the same case, in the same problem, is it understood right? First, let me know in a chat box. Is it understood right? Is it concept is understood right for everyone? Yes, Sujan. Good. Good, Jansi. Okay, now I'm going to add one more charge here. Charge idhar hai. Now tell me what is the flux value? Now tell me what is the flux value? Yes. Good, Bharat. Good, Yashaswini. Good, Sujan. Flux value will not same. Flux value will be same because charge which is out from the Gaussian surface, we are not going to add that one. Okay, we are talking about the flux only the charge which are present inside the surface. Clear enough? That too great. Good. Okay, we'll come across to the second application of the gas. Okay, previous application kya tha? Guys, देखो in a short way I will explain. Previous application था एक wire था linear charge wire. It has a charge just like this. Okay, ये दोनों एरिया से ये शेडेड एरिया है ना इसके वजह से फ्लक्स वैल्यू क्या हो गया 0 हो गया ये दोनों को वजह से. Only this cylinder portion, this is a cylinder means Gaussian surface. Okay, इस ऊपर का एरिया होता है ना इसके वजह से फ्लक्स निकल के आ गया हमको. ये फ्लक्स के वजह से हम कैलकुलेट किया इलेक्ट्रिक फील्ड इंटेंसिटी. वैल्यू विल बी लैम्डा डिवाइडेड बाय 2 pi r epsilon naught. Later on what we did actually I multiplied two numerator and denominator. That time electric field value will come out to be 2 lambda divided by 2 into 2 means 4 pi epsilon naught into r मैंने लिख दिया. This is the electric field intensity due to the linear charged wire, infinite length wire. Clear enough? And if anybody will ask that what is the direction of electric field intensity, means almost all direction will be upside. Okay, in this direction only electric field intensity will be takes place, right? Because in this direction and this opposite direction wala electric field intensity क्या होता है, that will be cancel each other. Clear, right? This concept, is it clear? Last class one. Yes. Okay, देखो इधर. Today electric field intensity due to an infinitely long thin plate sheets. Okay, plate sheet के वजह से electric field intensity क्या होता है देखते हैं. Okay, this is a plate sheet. Okay, it has a charges over the surface. Okay, here charges will be distributed over the surface area, not in a linear mode. Okay, linear charge density हम लिख देते हैं lambda is equal to q by l. करेक्ट ना? बट सरफेस के ऊपर चार्ज है ना इसका डेंसिटी लिखने के लिए हम यूज करना है इधर सिग्मा. सिग्मा वैल्यू विल बी q by a. इधर नॉट लेंथ, इट इज एन एरिया. वी नीड टू राइट हियर consider area. Yes, right pa. Okay, we need to consider the area. Okay, tell me that now we need to calculate the electric field intensity for this plane sheet. Now I want to write the Gaussian surface for this one, means what kind of area I need to take here. What kind of surface area I need to take. Sphere लेना है क्या? If you take sphere means is it will be give a symmetry? No. Then cuboid. Okay, rectangle. Okay, this is what idea, guys. Actually cylinder. Okay, if you explain different thoughts, no, whether it will be correct or not, it's a separate one. First you have to try to participate. Okay, then it is a good thing. Now we have to take actually a cylinder. ओके सिलेंडर लेना है, ले लिया मैंने सिलेंडर, बिकॉज इट विल गिव द सिमेट्री ओवर ऑल द प्लेट्स, प्लेट्स के ऊपर बहुत सिमेट्री देते हैं. इफ यू गोइंग टू टेक क्यूबॉइड मींस ट्राई कर लो, क्यूबॉइड में आता है, कोई प्रॉब्लम है, कोई प्रॉब्लम नहीं. ओके बट इन अ कॉर्नर वाइज व्हेन यू आर राइटिंग द क्यूबॉइड, देखो इधर like this cuboid will become no, right? From this point if you're going to place the sheet here means, okay, the distance here corner to the corner will be more. Okay, I think it will not give a correct answer. Okay, that's why almost all everyone will take the cylinder only, because cylinder का area बहुत अच्छे से आता है, आंसर भी आता है easy से, that's why कोई प्रॉब्लम नहीं, राइट? विल मूव ऑन, टेक सिलेंडर इटसेल्फ, कोई प्रॉब्लम नहीं, सिंपल से आता है आंसर. दिस शीट, शीट के वजह से फील्ड लाइंस विल बी मूविंग रेडियली आउटवर्ड डायरेक्शन लाइक दिस, दोनों साइड से कितना इलेक्ट्रिक फील्ड लाइंस आर देयर, नो दे आर मूविंग आउटवर्ड डायरेक्शन लाइक दिस, राइट? नाउ सिमिलर भी देखो इधर क्या क्या लेना है. सिलेंडर ले लिया मींस इसका एरिया कंसीडर करना बहुत इंपॉर्टेंट है. नाउ इस सिलेंडर का एरिया, सॉरी लेंथ है एल, एंड इस सिलेंडर का रेडियस है x, or else you may take r itself, कोई प्रॉब्लम नहीं, राइट ना? देन नेक्स्ट थिंग, tip, the field lines remain straight line, parallel and uniformly spaced, means uniformly spaced lines will be available here. Guys just a minute, just a minute. Sorry guys, actually, okay, look at here. Now I'm going to consider the first area here. Okay, in this area, actually area का vector इधर होता है, correct ना? Yesterday in class also I explained this is a area element I took. Okay, at this point only electric field intensity due to these charges will be moving in this direction, in the same direction, correct ना? This is a first area. In a second area I'm considering B, which is present here, left hand side. Okay, मेरा left hand side, आपको भी left hand ही होता है इधर, correct ना? And this इसका area B will be opposite to the first one. Electric field also moving in a same direction. What is the angle between them here for the first area? Let me know. First area के लिए angle कितना होता है? Good, good. First area के लिए angle होता है इधर 0, because both are moving in a same direction. Yes, good. For the second one के लिए here also 0 degree, theta value here also 0. Okay, now we have a third surface also for the cylinder, correct na? ये surface है ना, this is the third surface. For this third surface, if I'm going to take the area here, C point, okay, area vector will be looking upward direction, but at this point also electric field lines are moving in this direction, curved surface. Yes, yes. Okay, now देखो इधर angle between a area vector and the electric field lines will be becomes here 90 degree. Okay, yes, good. Now I have a question. If angle between the electric field lines and as well as area vector will be 90 degree means, is there any flux will be available from the surface, curved surface? Yes, Sujan. Flux value क्या होता है इधर? 0 हो जाता है. Right. Remaining two things are there. No, from these two things only we will get maximum electric field lines. Means flux मिलता है. कैसे मिलता है? देखो इधर. According to the guass law, flux in a closed integral value will be equals to q by epsilon naught, means E dot ds value will be equal to q by epsilon naught, correct now? Okay, we'll apply this q by epsilon naught value. We will apply this q by epsilon naught value for the two surfaces here. This surface available, it will be 0, कोई problem नहीं. ये दोनों surface के लिए apply करना है. First surface E dot ds, for the second surface also E dot ds, and third surface also E dot ds. Now we will apply this one along with the angle. Angle से apply करने से क्या मिलता है? E dot ds cos theta. Here theta value will be 0. Hence we will get here flux in a first place. Coming to the next one. Next one में same E dot ds cos theta. Here also angle will be 0. we'll get a flux. Third one, E dot ds will be cos 90. 90 value 0. That's why flux value here 0 hota hai. Remaining two things guys here. देखो इधर cos 0 means 1. Here also cos 0 means 1 hota hai. Correct na? The remaining term will be E dot ds plus E dot ds. Correct na? Then it will be equal to 2 times the E dot ds. It will be equal to 2 times the E dot ds. Correct na? In a closed integral. Now E value field due to this charge distribution will be constant, and then constant, take these two constant things to outside of the integration. We need to integrate this ds area. That's it. ds area means chota sa area what we took here. No, dekho idhar, whatever the area we took here, no, this is the ds, blue color wala, right? We need to integrate this one for a whole area ke liye integration karna hai. That's it. Clear na? Now dekho, up to this point we got 2 times c. We need to integrate ds, corner wala. Correct na? I'm going to continue this derivation on next page. Please stay with this derivation. Okay. Next page में क्या है देखो. Simple. We got in a previous slide. That is E flux value will be equal to E dot ds. Sorry, 2E dot ds integration करना है. Correct ना? Okay. Flux value will be equal to 2E. Here ds है. Okay. If you're going to integrate this ds means we'll get a total area. Total area क्या है इधर? I will write area. ये. Guys, may I know what will be the area of this cylinder? This one. What is the area? What is the area? Area formula क्या है इसके लिए? Yes, Rajan, right, bro. This is actually like a, how it is there? Circle. Hare yaar, that is volume of the cylinder, bro. I'm asking this one, only this area. In this area only the flux is coming. It is pi r square, right? Okay, this area, those who don't know, try to write down this one, pi r square. Circle का area है यार, front side of the circle. That's it. Clear है ना? Then we will get 2e into ये को इंटीग्रेशन करने से क्या मिलता है आपको इधर? देखो इधर शॉर्टकट में लिखता हूं मैंने. 5 value is equal to 2 times the e into pi r square. Okay, उधर x square ले लेते हैं. x also ले लो, कोई प्रॉब्लम नहीं, or else r ले लो, it is better. Okay, and then okay, flux value मिल गया. According to Gauss law, flux value क्या? It is equal to actually q upon epsilon naught. Correct ना? q upon epsilon naught के लिए इक्वल होता है. देखो क्या होता है इधर लिख दिया मैंने q upon epsilon naught. इधर क्या चीज है, कैसे आ गया, कुछ भी नहीं पता होता है. If I'm not explaining this, देखो already I told you that charge है ना, this is charge inside the surface what we are considering. We need to explain this one in terms of surface charge density. In the last derivation we explained that one linear charge density. Here we have to explain this one as an surface charge density. Surface charge density के लिए sigma is equal to q divided by epsilon naught. Means guys इसके अंदर ये एरिया है ना, इधर एक एरिया है, देखो I will write in a red color. देखो इधर भी एक एरिया है. ओके, ये एरिया के अंदर कितना चार्जेस प्रेजेंट है उसको कैलकुलेट करना है हमको. करेक्ट ना? q by epsilon naught. Now in place of q we can write this one as an sigma into epsilon naught is equal to q. Shall we write like this? Oh, sorry, it is by mistake happen. Sorry guys, what is that? This is by mistake. Charge per unit area, right? Sorry, charge per unit area. Okay, it will be sigma into area is equal to q होता है. देखो इधर q क्या है again? Sorry, area क्या है? This is the area, red color वाला. देखो इधर, this is the area again. This is also area of the circle only. Again, like this end we took, no, same area present here. Correct now? That's why we have to take here area as an pi r square. Correct now? Then sigma into A means pi r square is equal to Q. Means we need to substitute in the place of Q pi r square into sigma. इधर आ गया. Correct now? And in a denominator as itself epsilon naught. Clear है ना अब तक? Up to for everyone, right? How I took and what I'm doing. Is it clear for everyone? Cool. Yes. Guys, let me know. This is very important as per the NCERT also. Yes, good. Good, good. Okay, देखो इधर. Actually, मैंने ले लिया था right hand side में देखो Q phi is equal to Q epsilon naught. ना इसका वैल्यू इक्वल होता था 2e pi r square के लिए. करेक्ट ना? देखो इधर 2e pi r square value will be equal to Q by epsilon naught means Q by epsilon naught means इसका वैल्यू किसके लिए इक्वल हो रहा है? सिग्मा पाई r square by epsilon naught के लिए इक्वल हो रहा है. Right now actually our intention is to find out the value of electric field. Then देखो इधर pi r square cancel, and then electric field intensity if you want means take this 2 to right hand side ले लो. Then E value will be equals to इधर sigma बचा हुआ है divided by 2 will become here means you will get sigma by 2 epsilon naught. Sigma by 2 epsilon naught you will get. Okay, this is the actually electric field intensity due to a charged plane sheet. This is very very important. Guys, लिख दो इसको. Right? If you are understood this one means लिख दो, or else if you are not understood means in a short way I will try to solve this one. देखो इधर सिंपल सा है, कैसे सॉल्व करना है बोलता हूं मैंने. What we took actually flux value हमको मिला था Q by epsilon naught. Correct ना? And also while we solving closed integral E dot ds इधर हमको मिला था 2e into ds के लिए एरिया पूरा एरिया इंटीग्रेशन करने से हमको मिला था pi r square. करेक्ट ना? दिस इज एक्चुअली इक्वल टू E dot ds. ओके, एक्चुअली गास ने क्या कहा था? E dot ds वैल्यू विल बी इक्वल्स टू Q by epsilon naught बोल दिया था उन्होंने. करेक्ट ना? इधर if you're going to integrate or integration this one we got this answer. Correct now? 2 times the E pi r square will be equals to Q by epsilon naught. Right now? Now actually Q is the charge, one charge. Either charge actually distributed. That's why we need to take the density of charge. Okay, here surface charge density aata hai. On solving surface charge density, we will get here 2e pi r square is equal to, in the place of Q we will write sigma into A divided by epsilon naught. This A value hai na, this A value also equals to pi r square. Hence this area, this pi r square will be cancelled, and then take 2 to left hand side. Then E value will become to be sigma by 2 epsilon naught. Is it clear now? Is it clear now? Let me know. फास्ट हो रहा है क्या? Are you there? Are you there? Or if you are not understanding means please let me know in a chat box. Okay. Is that concept is boring? Then why you people are not responding anything here? I want to know. Swastik, Swati, Itish. What you people are doing? Janvi Mandya, Bhuvan, Sachin. Okay, done. Good. Okay, guys, if it is clear means, okay, I understood you people. Okay, we'll solve one problem. Okay, प्रॉब्लम करेंगे आज. एक प्रॉब्लम है. क्या है ना प्रॉब्लम? सुनो, ध्यान से सुनो. I will explain the problem first. Okay, ध्यान से सुनो इधर. It is actually based on the potential. This is the point O. Okay, a point O के ऊपर I actually kept 1 microcoulomb charge. This is a plus 1 microcoulomb charge. Okay, and at a distance 2 meter, at a distance 2 meter, point A is there, and at a distance of 1 meter, point B is there. Point B is there. Guys, may I know what is the potential difference? VA minus VB का value क्या होता है? Who will tell me first? I'm waiting for your answer. Take 1 minute of time. Okay, this is a neat question. In a simple way, I explained this one. This is a neat question. Let me know what is the potential difference due to this point charge which is kept at O. Potential difference, how to calculate, do you know, right, guys? अरे यार यशस्विनी, how it is? Potential difference के लिए फॉर्मूला क्या आ गया था? V is equal to K Q divided by R, right? K Q by R आ गया था. Now we need to take the potential difference. Yes, of course, means VA. देखो इधर VA, if I'm writing means I want to write. Okay, देखो इधर VA is equal to K Q divided by R means VA का distance कितना दूर में है? 2 meters. Hence we need to take here 2 meter. Clear ना? Then K value substitute करो. K value कितना होता है देखो. Or else first try to write down this one. Okay, VB similarly K Q divided by R value will be 1 meter. Now we need to write the VA minus VB. Correct ना? VA minus VB लिखना है इधर. Yes. We'll check this one. Okay, यशस्वी will check. Now देखो इधर VA minus VB is equal to VA का value KQ divided by 2 meter, correct ना? Minus VB का value KQ divided by 1 meter. ये दोनों इक्वेशन में KQ is a common. Take it outside. KQ if you going to take outside means 1 by 2 minus 1 by 1 is nothing but 1. Correct ना? 1 by 2 minus 1 means what is the value of 1 by 2 minus 1? Minus 1 by 2 होता है. Minus 1 by 2 होता है. Meanwhile here potential difference will be equals to, yes, right. Okay, minus 1 by 2 minus K value will be 9 into 10 to the power of 9 into Q value 1 microcoulomb. Micro means 10 to the power of minus 6 divided by 2. Correct now? 9 by 2 is nothing but 4.5. 4.5 into 10 to the power of minus 6 plus 9 minus 3. Okay, this is what the potential volt. Clear, right? Means potential difference will be comes to be minus 4.5 into 10 to the power of minus 3 volt. But in NEET question itna easy nahi tha. Okay, actually what they told, no, what they told after this one, they told that if I'm going to change the place of A, place change कर रहा हूँ कैसे? देखो इधर point O इधर है, point A will be same place 2 meter. If I'm going to place the point B like this at this, now actually axial में था, now I'm placing this one at equatorial point, point B at a distance of same 1 meter. Now tell me the potential difference of VA minus VB they are asking. Now tell me, what is the value of VA minus VB? This is an interesting questions, guys. Okay, देखो कितना अच्छा क्वेश्चन है. Think करो. Same. ये भी value will be same, bro. Distance will be same. Guys, think once you think, is that potential is a scalar or vector? Is this potential is scalar or vector? Hello. Yes, good Shashini. If it is scalar means, is there any dependence direction? Direction के ऊपर depend करता है क्या? No. Then the same distance they are present now. Okay. Then the value of potential difference also same. Right? Same ही आता है. कोई problem नहीं. देखो कितना अच्छा question है NEET में. Right? Try to concentrate over like these questions. Good. Understood, right? Question is understood. Is this question is understood, right, for everyone? Give me your response in a chat box quickly. Yes, Purnima. Yes, Swati, right, pa. Ballari, right. Sagar, right, bro. Good, Sagar. Good, Bharat. Clear now? Good. Now I have a small means little energy. अब मैंने actually energy boost किया मेरा. आपका reply है ना? If you give the reply means I will get boosted my energy. Okay, try to give the reply when I'm asking the question. Clear? Okay, we'll move on to the next concept. Actually, this concept is very important for your board examination. Okay, simple से derive करके बोलता हूँ. क्या है ना? देखो इधर deduction of Coulomb's law from the Gauss theorem. Gauss theorem utilize करके we need to explain the Coulomb's law. कैसे? देखो इधर एक स्पीयर है. ओके, स्पीयर के अंदर एक चार्ज रखा हूं मैंने. चार्ज इज प्रेजेंट एट द सेंटर ऑफ द स्पीयर. ओके, ड्यू टू दिस स्पीयर, ड्यू टू दिस चार्ज, इलेक्ट्रिक फील्ड लाइंस आर मूविंग रेडियली आउटवर्ड डायरेक्शन. Among those all the electric field lines, I choose only one electric field line. Okay, at the surface I am considering the Gauss law. Okay, Gauss law का distance r होता है from this point, means r value will be same no from everywhere in a complete circuit. Sorry, complete circle, r value will be same. Correct ना? एक छोटा सा एरिया का, yes, right pa, right. For this small area a vector direction will be along with the direction of electric field line in the same direction होता है. And then from Gauss law, what is that Gauss law? In a closed integral E dot ds, surface integral, that is also surface integral, E dot ds value will be equals to q by epsilon naught. Correct na? Then देखो, since E and ds are in the same direction, and then flux value E dot ds will be, E dot ds means E ds cos theta. Cos theta value will be here 0, hence the value will comes out to be 1. That's why E ds is equal to q by epsilon naught. Correct na? And then or else we can write this one, E take outside because the value of E will be constant, and ds area we need to calculate, means this is another area, this is another area, this is another area, this is another area, like this all the areas we need to integrate. Yes pa, right. Okay, look at here again, इधर E value लिख दिया मैंने, ds value, if you going to integrate the ds, okay, this is छोटा सा area. Okay, look at here, this is a small area which we are taking here. Okay, ds, if I'm going to integrate all the area, means what is the area of the sphere? It is nothing but 4 pi r square. Area of the sphere will be, लिख दो 4 pi r square. Just it is a circle, means pi r square is equal to remaining part will be q by epsilon naught. Correct ना? Actually we need to deduction here Coulomb's law. Coulomb's law means force explain करना है आपको इधर, right ना? Then rs देखो, I will take 4 4 pi r square to right hand side, then it will become q divided by 4 pi epsilon naught into r square. Just I'm taking cross multiplying that one, right? I'm getting a q divided by 4 pi epsilon naught into r square. Just multiply that one here. Okay guys, you guys know force value क्या होता है? Q into E होता है in electrostatics. Force value will be equals to Q into E. It's exactly right. देखो E value है already. We have an E value. Correct ना? Substitute this value in this equation. देखो substitute करने से क्या मिलता है आपको? F is there, force, Q, E value means substitute करने से Q, E value will be here, Q divided by 4 pi epsilon naught into R square. देखो actually this is the Coulomb's law, right? We derived this Coulomb's law very beginning of the class itself. I think second class of the, yes, this academic year we studied this one. Yes, exactly right. We can also write this one as an K Q square by R square. Here 1 by epsilon naught is there, no, that is the value of K, Q into Q, Q square divided by R square. Okay, for your CBSE portion it is very important. Okay, 3 marks question पूछ सकता है इधर से. Is it clear, right? How we deduct the Coulomb's law? Is this Coulomb law is clear, right, for everyone? Yes. Good. Okay, if it is clear means we'll go through one more concept. Okay, ज़्यादा नहीं बोलता हूँ मैंने. Okay, based on this one, this is also application of Coulomb's law. Okay, this is also guys application of not Coulomb's law. Coulomb आ रहा है आज. Okay, this is application of again Gauss law. Okay, Gauss law का और एक application है. क्या है? Electric field intensity due to uniform charged spherical shell. Spherical shell means it is nothing but actually we are taking here hollow sphere. Hollow sphere. Hollow sphere means empty sphere. We are taking here actually empty sphere. कैसे होता है? Yeah, देखो. First we are considering the point outside the sphere. First देखो इधर, this is a hollow sphere. On this hollow sphere actually we distributed the charges over the complete area. Either actually you might be looking to here. This figure shows that uniform distribution of charges over the sphere surface. Okay, ना? First point क्या है? We are find outing the electric field intensity. Always in a Gauss law we are find outing the value of E only. Okay, E value we are find outing at point P actually which is situated at the outside of the shell. ये shell है, outside of the shell we are considering. Correct ना? Wait, देखो the center of the sphere and this is the radius of the sphere. The hollow sphere मैंने बोल दिया मैंने. Okay, this is a charge distribution. Here guys, may I know what is the charge density here? Whether it is a surface charge density or volume charge density. Give a response in the chat box once. Okay, cool. Yes. Right. Surface है ना? Right. Okay, first we will consider the point. Okay, this is a point. Okay, which is actually situated very far away from the surface. Okay, point P. This is at a distance R from the center. Okay, distance है ना? This is actually at a distance R, small r. Capital R is the radius of the spherical sphere, and point P is the where we need to actually calculating the value of electric field intensity, which is actually situated at the distance of R. And this dotted line है, this is actually Gaussian surface. क्या है ये? Gaussian surface है. Okay, देखो इधर Gaussian surface, how it is helpful for to find out the electric field intensity. You will get realized from this point. Okay, at this point first we need to write or take a small area. Okay, देखो इधर, this is a small area. Due to this small area, what will be the flux we need to calculate? Actually देखो, this is a surface charge density. Due to all this surface charge density in this area, कितना electric flux आ रहा है दिखना है. Okay, ds area का area element direction will be outside direction, and as well as the electric field value also in the same direction. Okay, here also angle will be between a E and as well as dA is equal to 0. Yes, Yashaswini, right? Cool. Right now according to Gauss law, what we need to write here in a closed integral, E dot ds is equal to q by epsilon naught. This is must and should, guys. Whether I don't know, you have to, whether you are going to by heart this one or you are going to remember this one for all long time. I'm not going to take this serious, but at any cost you have to know this equation. Okay, without this equation you can't able to derive any point here. Okay, electric flux value will be equals to, in a closed integral, E dot ds value will be equals to q by epsilon naught, and this q will be actually present enclosed inside the Gaussian surface. देखो Gaussian surface के अंदर charges है ना, right? Let me know in a chat box. Charges are present inside the Gaussian surface, right? Yes, then flux will be available here. Yes, Purnima, right? देखो next step. And I already told you E value and as well as the area element are in the same direction. Hence, angle between them will be 0. Hence, E dot ds here. I explore this one E dot ds as an EDS because already theta is solved here. EDS value will be equals to q by epsilon naught. Then we need to integrate the area. That's why take this E2 outside of the integration. If I'm taking E as an outside of the integration, we need to integrate this area element only. Okay, this is the value will be equals to q by epsilon naught, right? And then if I'm going to integrate this ds area, we will get again sphere area क्या है, already मैंने बोल दिया था 4 pi r square, right? Then E into 4 pi r square value will be equals to q by epsilon naught, right? What I'm saying now, guys, देखो इधर, actually we need to find out the value of E, correct ना? Take this 4 pi r square to right hand side. Then if I'm going to take this one right side, means we will get E value will be equals to q divided by 4 pi epsilon naught into r square. Is it clear for everyone? Actually, this is the value of electric field intensity due to sphere outside of the sphere actually. Okay, this is a shell at a point where it is situated outside of the sphere. No, this is not a point charge. This is not a point charge. I will tell you that one. Okay, we can replace this one also, कोई problem नहीं. If you are going to replace this one, no, q charge को again surface charge density है, means sigma value will be equals to q divided by, sorry, area means 4 pi r square. Okay, then q charge will be written as sigma is equal sigma into 4 pi r square is equal to q. Now you can replace this one here. Okay, मैंने बोलता हूँ, कोई problem नहीं. देखो इधर charge value will be equals to sigma into 4 pi r square. This r square is actually, guys, radius of this sphere, hollow sphere what we took, no, that is the value here. But small r square is the value of point P where we are considering. ये दोनों में फर्क है, स्वाग भी अलग है इधर, right? Is it understood, right, up to this point? Yes, cool. Done. Okay, if I'm going to replace this value, देखो, then value will be sigma r square divided by r square आता है. देखो simple है इधर, it's very simple. We got a equation. I will write in a separate page. Where? Okay, look at here. This is a sphere. Okay, point we consider here. Okay, this is actually surface, Gaussian surface, which is actually situated at a distance of r. If I'm going to consider these are uniform charge values, okay, electric field intensity we got here, electric field intensity we got here, कितना आ गया था, q divided by 4 pi epsilon naught into r square आ गया था, correct ना. Now actually charge value क्या लिखना है इधर, surface charge density value into area, that is 4 pi capital R square. If I substitute this value here, no, we will get here E value will be equals to sigma into 4 pi R square divided by 4 pi epsilon naught into R square. This 4 pi get cancelled, no, then electric field intensity value will become to be sigma into R square divided by R square epsilon naught. Clear na? देखो इधर, this is a simple method how to find out the electric field intensity. Yes, right? I think, good. Right. Hope it is understood to everyone. Last answer we got sigma by epsilon naught R square divided by small r square. Clear now? This is the first point or first consideration we took outside the sphere at a distance r. Next point क्या है ना, case है. Okay, if you know the first case means these two cases will be, yeah Kiran, I will do. देखो, is this slide you want? This one or where I solved in a separate sheet, that one you want? Yes. Okay, take a screenshot, bro. I need to solve. So, okay. Look at here. Now, same case, I'm considering on the surface of the shell के ऊपर consider कर रहा हूँ मैंने. Okay, इधर derivation same है, सब कुछ same है. I'm not going to explain derivation in a simple way. I'll go last slide, sir, again. Yes, bro, wait. Bro, take a screenshot. Try to take a screenshot. Okay, कोई problem नहीं. No need to ask any pleasing word. Is it all right? Okay, देखो इधर second point है on the surface I need to consider the point, means surface के ऊपर ही point consider करता हूँ. सब कुछ same ही है, derivation part वगैरह. Okay, but the changing point is that actually we got a electric field intensity like this. देखो इधर last slide में E value will be Q divided by 4 pi epsilon naught into R square आ गया था. This is the R square, actually point P where we consider. Now I'm considering the point P on the sphere, means this R value, look at here, R value is equal to radius of the sphere, no? Radius of the sphere. That's why now electric field intensity on the surface, if you consider for the shell, we will get Q divided by 4 pi epsilon naught into R square. In the place of small r square, you have to write here r square, because the distance from the surface to center of the shell will be only r. This r value will be equals to small r. Clear enough? सब कुछ same है, सब कुछ same है. There is no change. Okay, and then lastly we solved one more equation. What is that? Sigma value आ गया था उधर. Sigma capital R square divided by epsilon naught into small r square. Here actually guys, I took r value equals to r, no, because on the surface, that's why sigma value will becomes here sigma by epsilon naught into r. Yes, both are same, r square by r square. Hence these two will be cancelled. We will get sigma by epsilon naught. Sigma by epsilon naught on the surface. This is the electric field intensity due to uniformly charged shell on the surface. Is that clear? Same hai. First we need to take the Gauss law and then we need to integrate the surface area. Correct now? This is actually equals to Q by epsilon naught. That's great, Ashwini. Okay, and then if you're going to integrate the area, means you will get 4 pi r square. This value will be equals to Q by epsilon naught. You want to calculate the value of E, that's why take 4 pi r square to right hand side, then it will comes to denominator, right? Then you will get an answer Q divided by 4 pi epsilon naught into r square, and Q is the single charge. Now you have to explain this one in terms of charge density. Correct now? This is a surface charge density. That's why surface charge density value will be equals to Q divided by area होता है. Correct ना? Charge का value कैसे निकलता है इधर? Sigma into A is equal to Q. Area का value will be equals to 4 pi r square into Q. Substitute and we'll get a E value as an sigma by epsilon naught. Is that clear? Yes, that's great. Last point है. Okay, last point का answer without calculation I will take the answer from your end itself. देखो इधर last point A है at the point B inside the shell. Now point B है inside the shell. मान लो this is a point B. Okay, at this point we have to find out the electric field intensity. If this point I want to find out the electric field intensity, means I need to draw a Gaussian surface over here. Okay, मैंने draw किया Gaussian surface इधर. Okay, देखो inside the Gaussian surface is there any charges are present? Tell me in a chat box. Is there any charge will be present inside the Gaussian surface? Are you there? No, right, Abhishek? No, right? This is a Gaussian surface, means inside the Gaussian surface there is no charges. Correct now? According to Gauss law, if there is no charges present inside the Gaussian surface, means is there any electric flux? Flux value Q by epsilon naught है. Q का value इधर 0 है. 0 by epsilon naught means flux value will be 0. If flux value will be 0 means electric field intensity value also 0. Right, what I'm saying? Exactly right. But if you're going to do this one in a CBSE exam like this, in this pattern, you will get 0 itself. आपका CBSE teacher 0 देता है. Clear ना? Try to find out. Actually, I'm going to give this one as an homework. Okay, this is a homework question to all of you. Okay, try to find out the value, E value as in 0. You have to consider this one inside the surface itself. Clear, right? Guys, this is a homework to all of you. I will post the notes in the drive. Okay, try to download the notes in a drive and solve this one. Is it clear? 0 आना है. कैसे आता है 0? Similarly, as usually, you have to consider the Gauss law. Okay, Gauss law consider करके apply करना है. Last तक करो. Okay, last point में, if you want 3 marks in a CBSE exam, means you have to do everything. Okay, in the last step you have to substitute the value of 0. Okay, in the last step you have to substitute the value of 0, then electric field value will be 0 आता है. No need to do that like this in a NEET or JEE exam. Okay, JEE exam में इतना step करना जरूरत नहीं है. Clear ना? In a CBSE exam, this is must and should. Is it clear? Shall we wind up this session? Okay. Okay, guys. Thank you so much for your attention here. See you in tomorrow class. That's great, buddy. Bye.